Welcome to Cybersecurity Workshops and this lesson on network services. So this is from the CyberRange course called Cyber Basics, and we're in Module 2, the networking module. We've talked about some very introductory networking concepts. We've talked about some network fundamentals, and we've taken a look at the TCP/IP network stack. So now we're going to talk about some different network services, and you'll sometimes hear those referred to as daemons. So some learning objectives. So we're going to talk about the client-server networking model. Then we're going to take a look at some basic network services, and we'll talk about what a service is and when we talk about client-server networking. And the services we're going to look at are dynamic host configuration protocol, domain name service, web servers, HTTP and HTTPS, the file transfer protocol, and then the secure shell. And these are exemplary. So these are examples of network services. Certainly not an all-inclusive list, but this short list should give you a pretty good sense of this whole notion of network services. So network services operate on what we call a client-server networking model. So servers offer services, and a great example of a server is a web server, right? So websites using HTTP, that's the standard protocol of the World Wide Web, those HTTP servers are providing a service. They're essentially standing by waiting for a client to request a web page, and that client is a web browser. So that's a great example of a service on the internet, and there are many thousands of web servers running on the internet. A secure shell, so this is a service that's offered by some systems, and it's meant for remote access to systems on the internet. And then email uses this client-server model. So there's a protocol called Simple Message Transfer Protocol, or SMTP, and that's used by email servers to exchange email messages. And then clients connect to those services, right? So again, I'll go back to my web browser example, and I'll use web browsers as an example as I talk about the client server. So web browsers connect to web servers to display web pages, right? So you have a browser running on what we call a client computer, like a laptop, and it's going to request a web page from a server. Another example is email clients. Email clients connect to email servers to grab your email. So servers constantly listen for client requests. So a web server is constantly waiting for clients to connect and request web pages. And then clients request services over the internet from servers. So I'm going to see if I can quickly draw a picture of this on my whiteboard. See if I can make some sense of it. So let's say there's a web server out here on the internet, and we'll say that this is www.wired.com. So wired.com is a technology news website. And so that's out here in a network. And here I am on my laptop, and let's say I'm in the Virginia Tech network. So I'm on a laptop at Virginia Tech. So this is the vt.edu network. This is the wired.com network. And there's a device on the edge of the network, some sort of a router. We talked about routers and switches in our first networking lesson. So in any network, my computer is going to be connected to maybe a switch or two in between my computer and the router on the edge of that network. And the same is true with this web server, www.wired.com. It might have a switch that it's connected to, then there might be a router or two. And then you get to the edge of that network, and then in between here is the rest of the internet, right? So these two networks are going to be connected to the internet. And in the internet, you have all these routers that connect to each other. and some of these connect off to other networks. So lots of networks interconnected together through this thing called the internet. So here I am in my computer, vt.edu, and there's a web server, wired.com. And so that web server is constantly running, listening for hosts to connect to it. And the way I connect to it is I open my web browser on my laptop, and I browse to www.wired.com. And what happens next? Well, my computer needs to know the IP address of that host at www.wired.com. So the way I can look that up sort of manually, and we'll talk about how this happens here in a minute when your web browser does this. But if I want to look this up manually, I can go to my terminal window and I can use this network utility called NSLOOKUP, and I can look up www.wired.com, and I can see that it's at 199.232.66.194. So this computer is at 199.232.66.194. So it's got an IP address there on the other end of the network. And my computer here on the Virginia Tech network has an IP address that I can look up using another utility called ipconfig. And here I'm looking at my local area network network adapter. And so my IP address is 192.168.7.54. 192.168.7.54. Okay, so there's an IP address on my host machine here in the vt.edu network. There's a IP address on the wired.com web server. And so those are, if you recall from our last lesson, we talked about the TCP/IP protocol stack. Those are the pieces of information that network packets need to know to get from one end of the network to the other. So, you know, what would happen is that HTTP request that happens at the application layer would get handed down to the transport layer, then it would get handed down to the network layer, and these IP addresses, source and destination, would be put on the packet. Then that would get handed down to the physical layer, and this would get sent out on the wire. And that packet is going to go out my network, and it's going to be routed across the internet based on the IP address, right? So whatever that IP address is, that's going to allow my network traffic to get routed across the internet. And you see that there are multiple possible paths that that packet could take. And the reason for that is because depending on the load on these different links, maybe this packet, maybe there's a lot of load on this portion of the network, so maybe next time this packet would take a different route to get where it's going. But it's all about, you know, load on the network, and it's kind of like water through a pipe, right? The water's going to go through where there's the path of least resistance, and that's how network traffic works as well. But once my packet gets over to the wired.com web server, remember that web server is sitting there waiting for me waiting for me and others to request content from it. So that packet arrives at wired.com, and the web server is going to look up the response. You know, it's going to package this web page response, and then it's going to send packets back over the network, back to my computer at the Virginia Tech, in the Virginia Tech network. So that's my client computer requesting services from that web server computer on the other side of the internet. So that's client server networking. So the first protocol we're going to talk about, the first service that you need that your computer needs, is this thing called DHCP, or Dynamic Host Configuration Protocol. So this protocol is what gives your computer an IP address. So if you think of your laptop computer that, you know, maybe you just bought it at Best Buy, and you take it home and you open it up and you set up Windows 10, maybe you put in your username and your new password that you configured, but that setup process is never going to ask you for an IP address. But your computer has to have an IP address in order to function on the network, right? So how does that happen? That happens through this service called the Dynamic Host Configuration Protocol. So DHCP dynamically assigns IP addresses and other network configuration parameters to each device on a network so they can communicate. And so if you wonder where that DHCP service is running in your home network, it's running on your wireless access point. So on your home network, the DHCP server runs on your wireless access point. If I'm on the Virginia Tech network, then the DHCP service is going to run on servers throughout the university network. And if I'm in a corporate network, the same thing is true. And what kind of configuration parameters do I get from this DHCP protocol? Well, I get things like my IP address, right? That's very important, so that my computer has an address that it can use to send traffic to and from other hosts on the network. It gets this thing called a subnet mask, and that tells my computer, the scope and the size of the network that it exists in. So if you look at this example, here we have multiple computers, and they all have this same prefix, right? 192.168. something, and so the subnet mask, helps identify the scope and the size of the network that I'm on. The default router address is very important. So on this picture that we just looked at, my computer had to be able to send traffic out a router to get it out onto the internet. And in order to do that, my computer has to have the IP address of that router that it's going to send traffic to get the traffic out on the internet. So that information comes from the dynamic host configuration protocol information that is supplied to the computer when it connects to the network. And then it's got to have this domain name server address. Okay, and we're going to talk about the domain name service here in a minute, but in order to look up IP addresses for specific domain names, my computer has to know which DNS server to look to request that information from. And so the part of the DHCP process is configuring the DNS address. So here's the DHCP process. Remember, we're using client-server networking. So this client is a new laptop that's connecting to the network, and the server could be a wireless access point in my house. It's some system on the network that this computer is connecting to. So if you connected at a college, if it's a laptop that's connecting to wireless, then the DHCP server is going to be running in the wireless network. If it's a computer that you're plugging into the wall, then the DHCP server is going to be running, on some other device in the network. But it's got to be a server running on the network that I'm connecting to. And so since my computer doesn't have an IP address and it's connecting to this network for the first time, it doesn't know the IP address of the DHCP server. Okay, so that's a bit of a problem. I can't send traffic to that server if I don't know the address to send traffic to. So what do? Well, it's really fairly straightforward. I send a broadcast message, and that means that message goes to every host on that portion of the network, but only the DHCP server is going to respond to that message. So I send this very short discovery message, right? I'm broadcasting this to everybody on the network, so I don't want to send a whole bunch of stuff. I just want to send a very short request that says, hey, is there a DHCP server out there? If so, please answer me. That's this discovery message. And the next step is each of the DHCP servers on the network are going to respond. Usually that's only going to be one. Like if you do this on your home network, there's only going to be one DHCP server in your home network, and that's in your wireless access point. If you do this on a campus network, however, that message may reach multiple DHCP servers. So once that discovery message goes out, any DHCP server that receives it is going to respond to it with this offer message. And basically the offer message is offering to provide the configuration information to the new host. It doesn't provide that information, it simply offers to do so. Okay, why do I want to do it that way? Why don't I just provide the information? Well, I don't want multiple DHCP servers to provide conflicting information back to that client, right? I only want to get configuration information from one DHCP server. So once I receive those offer messages as the client, the next thing I'm going to do is I'm going to pick one of them and I'm going to submit a request for the configuration data. And that's going to make sure that I only receive the configuration data from one of those DHCP servers. If I receive it from multiple, then I may receive multiple conflicting IP addresses back, for example. And I don't want that to happen. I want to receive one IP address from one DHCP server. So I send the request, that's this message, and then finally the server responds with the acknowledge response, and it's going to provide the configuration data. So it's going to give you my IP address, it's going to give you my router, default router, and it's going to give me my DNS IP address. And that's who I'm going to do DNS request from. And once that happens, the host is now configured with information it needs to communicate on the network. And all that happens in a matter of seconds, right? So you connect a new device to your network, and that happens, essentially immediately. That's DHCP. The next service that's very important to your computer's functioning on the network is the domain name service, or DNS. And remember, if you're going to host, if your device is going to connect to a service on the internet, it has to have the IP address of that destination service. So if I go back to my picture, when I was going to request a web page from wired.com, I had to have this IP address of the wired.com web server. Now, when I looked this up on my laptop, I used I used a command line utility to do an administrative lookup of that, but that's not what your web browser does. What your web browser does is it sends a message to the DNS server requesting the IP address for a particular host name. Okay, so why don't I just type in the IP address to my web browser? Well, you can do that, but it's very hard for humans to remember all these IP addresses, right? It's easier for me to remember the domain name like vt.edu or wired.com. And so I type my host name into the address bar on my browser, and the browser is going to take that. It's going to submit a DNS request to the DNS server. DNS server is going to respond with the IP address of the server that I want to get to, and then now I can put that HTTP request into a packet that is routed to that server IP address. So here's a little picture of how this happens, right? DNS is a distributed database that provides a mapping from domain name to IP address, and this is hierarchical thing. So here I am at my computer on campus, and when I'm gonna browse to Amazon.com, what happens is my computer is going to send a request to the DNS server. It's going to say, hey, I need the IP address of Amazon.com, and now the DNS server is going to respond with that IP address, in this case 10.1.0.1, and now my web browser can actually make that request to this host that is at 10.1.0.1 and get the HTTP response back. And the DNS service runs on UDP port 53. So these services run on specific ports. And the reason they run on specific ports is so that the client knows what port to request the data from on the server that it's sending the traffic to. Okay, so the next service we're going to talk about is the World Wide Web. The web relies primarily on two protocols. You have HTTP and HTTPS. That's the hypertext transfer protocol, and hypertext transfer protocol secure. So HTTP and HTTPS protocols used by your browser to request pages and used by the server to respond. And then the other protocol is HTML, and this is this is how the actual content of the web pages is constructed. So, and web pages are simply files on a web server, right? Or files that are generated on the fly by the web server. So the client requests a file using HTTP, the browser finds the file and returns it using HTTP, and then the client interprets the HTML in that file and displays it. HTTP uses TCP port 80, HTTPS uses TCP port 443. But it's this client request and response process, typical client server. So let me just talk briefly about the HTTP and HTML on the web. Just when we'll talk more about this later on when we start talking about you know, how some malicious people might abuse web pages. So this is my simple depiction of the early World Wide Web model. You know, this is what I just described, right? My browser sends this HTTP GET request to the web server, and the web server is simply going to go out to the file system and it's going to look for the file that was requested. And here is the file, and it's this HTML file, right? So this is typical HTML. I have an HTML tag at the beginning of the file, then I have the header section, then I have the body, and this is going to have a whole bunch of HTML tags with the content of the page. And then at the end of the page, I have this close HTML tag. So that's sitting in the file system, and the web server is going to grab that file off the file system, and it's going to send it back to the web browser, and the web browser is going to display it in the browser. Okay, so that was the early web model where web pages were essentially files in a file system on the web server. So that system was not very vulnerable to malicious people doing malicious things on the internet. The reason people were able to start doing malicious things is because now the modern World Wide Web is much more sophisticated. So now what happens, and I'm using Google as an example here, this could be any web page that has any sort of data input on it. So Google, if I go to google.com, there's a form where I can type something in. And so what happens when I go to google.com is my browser is going to do a GET request. Web server is going to get that HTML file off the file system, and then it's going to return that HTML page, but in this case, the page is what's called a form. And the form has fields in it that people can type stuff into. And so as the user, I'm going to type stuff in to this form, and then that is going to get sent back to the server as an HTTP post request. And now the interesting thing here is now the server is not simply grabbing files out of a file system and sending it back to me. Now it's actually taking action on my behalf. It's manipulating data in a database, right? So it might request records out of a database and then respond with the contents of portions of the database. And the thing about a database is you can request data out of a database, but you can also change data in a database. So if I know what I'm doing with database languages and I type the wrong thing into this web form, I could potentially cause this database not only to return data that it shouldn't return, but I could potentially even get it to do things like manipulate data in the database or delete stuff in the database. So whatever I type into the form here is going to cause this web server to manipulate the database in some way. And then the web server is also going to grab this web page template out of the file system. And then it's going to dynamically generate the content that's returned to me. So this content is going to be unique to whatever I typed into this form. And so web pages now are created in real time based on things that we type into forms on web pages. And that is what makes the modern web more vulnerable than the old web, because now it's much more complicated and it's much more difficult to predict what a user might do on the internet, on the web. And there's more information about the HTTP protocol at the you know, there's a really good Wikipedia page that talks about the different formats for a GET request and then the response. And we're going to take a look in a later lesson at the actual packets and the data in the packets that are associated with this kind of a web request and response. Okay, we'll talk just very briefly about a couple of more protocols. One pretty popular protocol is the file transfer protocol. This is used to interact with file servers. So a file server is a system on the internet that has files that I might send back and forth to it. So FTP is used to transfer files between systems, and the user can upload files using the put command or download files using the get command to and from an FTP server. So these were once very widely used, a little bit less so now that we have things like Google Drive, but still a relatively popular protocol. And FTP uses TCP ports 20 and 21. And Windows, Linux, and Mac OS all have native FTP clients. So if you go to your Windows command line, for example, you could type FTP, and if you knew the domain name of some FTP servers out on the internet, then you could start interacting with them directly from the command line on your system. Okay, the next service we're going to talk about is Secure Shell, or SSH. SSH provides a secure encrypted tunnel to a remote system. So this allows me remote access to a computer on the internet. And of course, I have to have credentials to get onto that system, right? So I have to have a username, password to gain access. But the SSH protocol is what lets me connect to that system over the internet. And SSH replaces the old telnet command, which is not encrypted, right? So telnet was a way that I could gain, that I could log into a remote computer on the internet, but the communications was not encrypted. So anybody who could observe that web traffic could see the unencrypted messaging I sent back and forth, and that obviously is a security vulnerability. So SSH replaces telnet with a encrypted tunnel. And SSH uses TCP port 22. SSH also provides a service called SCP, or Secure Copy, and this is an encrypted file transfer protocol, which is often used as a replacement for the FTP protocol. Okay, so I'm going to stop there with network services, and next time we will dig a little bit deeper into the functioning of network security devices. So thanks for joining, and I look forward to seeing you next time.